This network, in the words of the police command staff, is running like a champ. Providence is a capital of Rhode Island. It's not a very large city. It's about 178,000 permanent residents, and that number doubles during the course of the day with inbound commuters. It's about 20 square miles. It's a very old city. It's founded in 1636, which means the buildings in the town range from really old, like the house I happen to live in, to very modern glass and steel structures. It has a fairly large police force, 600 people, 200 vehicles. Fire and rescue is about 500 people and 25 vehicles. Public safety, communications dispatch, which serves both police and fire and includes emergency medical. That's about 75 people processing close to 700 calls a day. So it's a very typical, I think, urban environment, but a small one that, from my point of view as CIO, it's pretty easy to get my arms around and get to build consensus and that sort of thing to get projects like this done. The requirements of this were very demanding. It is a public safety network, first and foremost. We will be using it for other municipal applications down the road, but the true driver of this project was public safety. We wanted broadband speed. This would be a low-speed broadband network by Ken DePietro's measurement, but we did want that. And it is citywide coverage. But the driver here was public safety. We will extend it to other city departments later on, but there will never be any public access on this network. It was designed from the ground up, in fact, to make it really difficult for the general public to get on this network and use it. We wanted personnel in the city to be able to use this network, and even if they were in a moving vehicle. In fact, the spec on this network was that you had to be able to maintain a session at 70 miles an hour. And in fact, the spec on the actual network, it's at least 70 miles an hour. It's probably closer to 125 miles an hour, which is far beyond what we have in mind for this network. The network was designed to assure a very high degree of availability. As the network loads change, the network responds, and in fact, the underlying technology routes every packet to the best available route at that moment in time. Every device in the network basically is a switch or a router. That includes the laptops in the cars, so as the cars move around the city, the actual configuration of the network is changing dynamically all the time. This network is very resistant to interference. We've had no reported instances of interference, and I think the reason for that is that the network, as I said, is very intelligent, and as it experiences interference, it finds a different way to get around the interference, and it's doing that in real time. Highly secure communications. The network itself, every device in the network is registered with a server. The MAC address is registered with a server. But beyond that, the equipment used in the network is not readily available to consumers. You can't go to Staples and buy this equipment. And that was, again, one of the advantages that we saw in the network. It's designed, in fact, for a very closed community of users. The applications itself that the network is running are also secure. The communications across the network are encrypted. So this is a network, again, that's designed for public safety. Also a high degree of survivability. When we put the design together, Katrina was still in the future, but this network is truly designed to take a hit of that magnitude. Temporary problems are really no problem. If someone knocks down a pole that happens to have one of our antennas on it, it's no big deal because the system routes around that automatically. and as a result, we can use city employees to do the maintenance and repair on the network. We don't need a special 24-hour service to do that. In a more extreme situation where a large amount of infrastructure, of the fixed infrastructure, is knocked down, we can, of course, since every device in the network is a router, we can move a car or a set of cars where we need a communications corridor. We can set that up very quickly and be back in business. And in fact, in a truly extreme situation where perhaps we lose the master antenna, we can still hop back through the city the hard way and through equipment that we can rent from FEMA, get back up to the big internet in the sky through satellite communications.